You are welcome to Eko Learners Support for WAEC and NECO candidates. I am your physics teacher. Today I'll be taking you on electricity.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
What are the objectives you want to achieve today? They are: describe resistors in series and parallel. Differentiate between resistors in series and parallel. Describe cells in series and parallel. Differentiate between cells in series and parallel. Solve problems involving series and parallel connection, resistors and cells. When we talked about resistor, don't forget, resistor is an electrical device that prevents free flow of current. A resistor can be likened to an enemy of progress. A resistor can be likened to a giant who does not want another person to pass through. So coming to our own, a resistor is an electrical device that prevents free flow of current. There are two arrangements of resistors. It could either be in series or parallel. When resistors are connected in parallel, the same potential difference flows through them. What am I saying? I need to emphasize, it does not matter the magnitude of the resistor. Resistor 1 could be 20 ohms, resistor 2 could be 15 ohms, and resistor 3 could be 10 ohms. It doesn't matter, even though they have different resistance, yet each of them possess the same potential difference. Reason, because they are connected in parallel. However, they have different current flows through them. So we need to know, we have established the fact that when resistors are connected in parallel, they possess the same potential difference but different currents. Also, we need to let us know that they are connected side by side. Now we are moving on to cell. Cell also has the arrangement which could either be series or parallel. But we need to know that cell is an electrical device in which chemical energy is converted to electrical energy. Now coming to the arrangement, series connection. When cells are connected in series, they are also connected end to end. We have cell 1, cell 2, cell 3. This arrangement is said to be series arrangement because they are connected end to end. We also have parallel arrangement in cells when they are connected side by side. But we also need to know concerning these two, that when they are connected in series, the effective cell is summative. That is, if the EMF of cell 1 is 2 volts, that of cell 2 is 2 volts, and cell 3 is 3 volts, you need to have effective cell by adding them together, 2 plus 2 plus 3, which is going to give us 7 volts. We also need to know that when it comes into parallel, even though they have 3, but I want us to know it's just 1 they share. So the effective cell is the same. It does not matter, it could be 3, it could be 4. Like we have on the board, we have 3. So if E1 is 2 volts, E2 2 volts, and EMF of the third one is the cell 3 is also 2 volts. And what is the effective EMF? The effective EMF is still 2 volts. Why? Because it's just 1 out of them they are sharing. In other words, that means it is not possible when cells are connected in parallel to have different EMF. The reason it's not FASO because it's just one they are sharing. And I want to emphasize here, because of JAMB and WAEC as well as NECO, that the question being asked is what is the effective, what is equivalent. Most of the students don't know the meaning of this. Each of them means total. WAEC seldom use total in their question again. What they use is effective, equivalent, net, combined. When you see all this, just know that each of them means total. So they are synonyms. Now we want to look at this example. A battery of 3 cells in series, each of EMF 2 volts and internal resistance 0.5 ohms, is connected to a 2 ohm resistor in series with a parallel combination of 2 3 ohms resistor. Draw the circuit diagram and calculate the following: effective external resistance, 2, current in the circuit, 3, lost volt in the battery. The first thing in series. Each of EMF 2 volt and internal resistance 0.5 is connected to a 2 ohm resistor in series. Can you see a battery of 3 cells in series? Each of them EMF and internal resistance is connected to a 2 ohm resistor in series with a parallel combination of 2 3 ohms. Draw the circuit diagram. That is the circuit diagram. I've done justice to that. The next one, calculate the effective external resistances. Like I told you, when you hear effective, it means total. You can decide another year to use another word, equivalent. You can decide to use another word, net. They all mean the same thing. So when we talked about effective resistance, if you check the resistances, we have both internal and external. But we have been told, we have been restricted to external resistances. So in these external resistances, we have both parallel and series combination. In order for us to be able to solve it, we take care of parallel first. So I will label it R1, R2, and R3 for easy. R1, R2, and R3. So I will start. Like we are told, for parallel, R1 effective of R2 and R3, because they are the one in parallel, equals to 1 over R2 plus 1 over R3. So I have it 1 over 3 plus 1 over 3. LCM 3, 1 plus 1. So I have my 2 over 3. That is 1 over R2 and 3. But that's not my final. So my R2 and 3, effective of R2 and 3 will give me 3 over 2, which is 1.50 ohms. But that is not what we are looking for, is total resistance. So R1 and R2, 3, which is my R total, equals to my R total equals to my R1 plus my R2 and 3, which is, what is my R1 here? That is 2 plus 1.5 ohm, and the answer is 3.5 ohms. So that is the answer, effective external resistance. Then the next, current in the circuit. If you read, it involves EMF. So for that, E equals to I into big R plus small r, where big R is the external resistance and small r is the internal resistance, and I is the current and E is the EMF. So we are looking for current. So I'll make I the subject of the formula. E equals to E, I equals to E over big R plus small r. And what is my total EMF? I'll come here. That my total EMF equals to, because they are in series, E1 plus E2 plus E3, which is 2 plus 2 plus 2, 6 volts. I've done that, and my R total equals to R1 plus R2 plus R3, which is 0.5 plus 0.5 plus 0.5, and that is 1.5 ohm. So I'll do justice to that by bringing here. So I'm having 6 over, what is my R there? 3.5 plus 1.5. And that one will give us 6 over 5. So my equals to 1.2 ampere. So I've done justice to that. And the last one, which is the lost volt in the battery. Using the same equation, follow me to this side. We have your lost volt. You use this equation. E, your E equals to I into big R plus small r. So your lost volt equals to I multiplied by small r. And so lost volt equals to, what is my I? 1.2 times, what is our R? 1.5. The answer is 1.8 volt. And like I said, we've done justice to the example, starting from the circuit diagram, which you have it on the board, then the effective external resistance. I told you we have both parallel and series. When you have both parallel and series, it is better you start with the parallel so that you will be able now to compress the parallel and form series with the other one. And that was what we did here. Haven't gotten it. Then we move on to, and I told you don't forget, effective, which means total, or equivalent, it means the same thing. Similarly, net, it means the same thing. When we looked at the current in the circuit, for current in the circuit, we're looking at E equals to I plus R into R plus. Why are we not using Ohm's equation, which is V is equal to IR? The reason is not faster because we are dealing with EMF and internal resistance. Please note that when you are dealing with EMF, you use E equals to I into big R plus small r. But when you are dealing with only potential difference, then you use Ohm's equation, which is V equals to IR. Very, very important. I believe you, with what we have done, you will be able to do justice to the practice question. I will give you 30 seconds to do that, and I'll be right back. Your ability to interpret the question. If you cannot interpret the question, you cannot put it down on the diagram. And that is what we have done. You can see, let's go into a voltage of 6 volts is connected across 2 resistors, 3 ohms and 6 ohms in parallel. So these are in parallel. Calculate the effective resistance of the circuit. Let's start with that. When we say effective, what do they mean? We are talking about total. And because they are in parallel, I'll label it R1 and R2. So our R total equals to R1 over R1 plus 1 over R2, which is 1 over 3 plus 1 over 6. And the LCM is going to be 6, 2 plus 1. So we are having 3 over 6. So R total will now be 6 over 3. So final answer equals to 2.0 ohms. So we've been able to do justice to that. Effective resistance of the circuit is 2 ohms. 2 ohms. The next question, total current through the circuit. If you look at it, we don't have internal resistance. So that means it is negligible. However, we still have to use the equation. E equals to I into big R plus small r. And because small r is negligible, then we are left with E equals to I big R. So our I, which is what we are looking for, equals will be E over R. And what is that? I equals to our E, which is 6 volts, and our 2. So the current in the circuit is 3.0 ampere. Do you get that? Let's do the third one. Current passing. Like I said, look at it. We have been able to see the current flowing through the two to be this. Now, is it possible for us to know the current passing through the 2 ohms? It is possible. It is possible. But I told you something a couple of minutes ago. I said the bigger the resistance, or the bigger the amount of resistance, the smaller the amount of current. So what are we going to do this? The first thing we need to do, we need to know the PD. We need to know the PD throughout the circuit. So what is the PD throughout the circuit? Which is what we also have here, because it has no internal resistance. Having known the PD, and we know that the PD in parallel is the same. So from the PD, we can know the current passing through 3 ohms. So by saying V equals IR. So what is our PD? Our PD is 6. 6 equals to I into what? 3 ohms. So our I equals to 6 over 3. So I equals to 2.0 ampere. And for you to know that your answer is correct, you can also go through by checking. Let's check it up for us to know that our answer is correct. For the second one, V equals to IR2. I'll call this IR1, which is what? I multiplied by what? 6. And this is our 6. So our I equals to 6 over 6, which is what? 1.0 ampere. If you add it together, it will give us 3 ampere that we got. So that is to know that. So you can cross-check it with what you have. And I believe if there is any mistake, you will be able to rectify it. For comment, observation, and any question, feel free to send to us through any of our social media that will be displayed on the screen. Thank you.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello students, you are welcome to Eko Learners Support for WAEC and NECO candidates. I'm going to be your physics instructor for today's lesson. Let's take a ride.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Our topic for this lesson is work. The learning objectives are as follows. By the end of the lesson, you students will be able to define work in physical contexts, give examples of work done on objects, solve related questions on work. Let's look at this scenario. Who is working? We have two pictures. From the pictures, we have picture A and picture B. Who is working? Is it the man in picture A or the man in picture B? Let's find out from the definition of work. What is work? Work is defined as the product of net force acting on a body and the distance moved in the direction of the force. Remember, force is defined as the pull or push of a body or an object. Look at the man in picture A. He's doing no work because no distance is covered. But the man in picture B is actually moving an object, which is the cube box, is moving it and covering a certain distance. So the picture B, the man in picture B is actually doing work. Work is also defined as the energy transferred from a body or to a body by exerting a force. And the SI unit of work is the joules. A joule is defined as the work required to exert a force of 1 Newton through a displacement of 1 meter. Therefore, we have work which is represented by W equals force times distance. Only on the component of the applied force F in the direction of the motion of the lawnmower, we have F horizontal is used to do work on the lawnmower. Work is done when the force applied to an object leads to its displacement. You can see from the picture, we have the girl carrying the box of books. That is the force by the person. She's pulling it herself. Then we have force of gravity acting on her, and we have the displacement. That is the distance she's supposed to cover. We have examples. Calculate the work done by a student who moved a bag of rice 50 kg from his mother's shop into a truck parked 50 meters away. We take G as 10 meters per second square. Work done equals force times distance. Now we take our force to be mg. That gives us 50 times 10. Remember, F is denoted by we have work done to be F times D. So we bring this down, we have 500 times the distance, which is 50. So that gives us 25,000 joules. Okay, practice question. How much work is done in lifting a 10 kg box 1.5 meters off the floor? Question 2. An object is moved with a force of 15 Newton across a horizontal surface. How much work is done if the object is moved 50 meters? I'll give you 30 seconds to do that, and I'll be right back. Let's bring out all our parameters. This is the mass, and this is the distance. And we have G, this time around, to be 9.8. So our M, as given in the question, is this, and this is our G, which could also be as either 10 meters per second square approximately, or we have it as 9.8 meters per second, and this is our H or G. So we are using MGH right now because we talked about the height, which is the same thing, either we are having the distance. So this is our H, and by the time you multiply it, you have 147 joules. The second question. An object is moved with a force of 15 Newton across the horizontal surface. How much work is done on the object? So we have here, work is force times distance. We have been given from the question, our force is 15 Newton by the distance, which is 50 meters. So that gives us 750 joules. For your comments, observations, and questions, kindly direct all your questions to the handles on the social media handles on the screen. Thank you. See you in the next class.